Alright, we're going to be looking now at integration resulting in inverse trig functions. Okay, so if we just have a look at our information sheet, you'll remember that the inverse trig functions arcsine, arccos and arctan, when we differentiate them, it results in these fractions. Okay, these rational expressions with an irrational base here for sine and cos, but arctan resulting in just 1 over 1 plus x squared. What we want to look at now is the integral of these. Okay, now we have seen these all, this makes sense going from here back, but we want to look at when we have something that is not as straightforward, how do we go about integrating? Needing to be able to recognise what we have, and to say, okay, when I integrate that, I should end up something that looks like and has an arcsine or arccos or an arctan in there. So let's go over here and we'll have a look at this particular example to start with. You'll notice, okay, we have this 1 plus 4x squared in the denominator, and the numerator just has a constant term. So we could write this as having a 9 out the front of the integral of 1 over 1 plus 4x squared dx. Okay, so the 1 over 1 plus x squared we'll recognise as arctan. But the fact is we've got this 4 here as well. Okay, so what we're going to do is utilise what we have here. We're going to try and write it in this form so that we don't have a coefficient of x squared being 4. Now in order to change that, what we need to do is to take out a common factor of 4. And so when we do that, we'll be left with 1/4 here plus x squared dx. Okay, and so we've got here 1 over 4. We can take that outside our integral, and so we've just got now 9 over 4 outside multiplied by the integral of 1 over 1/4 plus x squared dx. So now if we have a look, it is similar to what we've got here. So the 1/4 here represents the a squared that we've got. So if we just rewrite that so that it's written as a square, so we have 1 over, now that's the same as 1 over 2 squared plus x squared dx. So essentially our a is 1/2. Okay, when we have a look at this basic form. So that's going to integrate to 1 over a. Okay, so that's still our 9 over 4 at the front times 1 over a, so that's 1 over 1/2 arctan of x over a, which is 1/2, plus c. And we can just look at simplifying that more. So 1 over 1/2 is 2, so the 2 will cancel with the 4, and we'll be left with 9 over 2 arctan 2x plus c. Okay, so because we have these general forms here, we may as well use them. Okay, so when it comes to a problem, we can recognize that we can integrate it to an inverse trig function. Then let's rearrange it so that it's in this form, and then go from there. Okay, so let's look at this second example. We can see here this is going to result in either a sine or a cos inverse function, and so really and truly it could be either. As we can see here, the integral of this one here, 1 over the square root of a squared minus x squared, will be arc sine x over a plus c, or negative arc cos x over a plus c. So it can be either. So let's look at what we've got. Again, we want to have our coefficient of x squared to be 1. So in order to do that here, we need to take out that common factor. Okay. So if we take out 3 from here, we'll end up with 4 thirds minus x squared. Okay. And then obviously we need to take out the square root of 3. So if we shift 16 over the square root of 3 outside the integrand, so that's 16 over the square root of 3 times the integral of 1 over the square root. Now the 4 over 3, we can write that as something squared, so that's going to be 2 over the square root of 3 squared minus x squared dx. Okay, so our a in this case is 2 over the square root of 3, and then we can go from there. So 16 over the square root of 3 times its arc sine x over a. Arc sine x over 2 over square root of 3 plus c. Okay, a little bit ugly at this point, so we'll do some changes. And typically we don't write our denominators as irrational numbers, so that can change to 16 root 3 over 3 arc sine, and this will be the square root of 3 over 2 times x plus c. Okay, alright, we'll do another one. This time the integral of 8 over 9 plus 5x squared. So we can see that this is going to be the arc tan. Alright, so we want to have this 5 taken out. Alright, so integral of 8 over, and we'll take out the 5, and we'll have 9 over 5 plus x squared dx. We can take out the front, the x over 5, and we're left with 1 over, and let's write the 9 over 5 as a square, so that'll be 3 over square root of 5 squared plus x squared dx. And now it's in this form, we can go from there. So the 8 over 5 times, now it's 1 over a, so it's 1 over, our value for a is 3 over the square root of 5. So that's 3 over the square root of 5 times arctan of x over a, so x over 3 over the square root of 5 plus c. And we'll do a couple for a couple of lines here. 8 over 5 times this will be square root of 5 over 3 now, times arctan of square root of 5 over 3 times x plus c. Okay, so we can combine that together then. That'll be 8 root 5 over 15 times arctan root 5 over 3 x plus c. Okay, so hopefully that kind of makes it clear of how to go about doing those integrals that which you'll recognise will lead to an inverse trig function. Okay, so we'll stop there.